Hi guys, this is O-level chemistry, paper 11, November 2022, question 31. Two statements are given. Statement 1, going down group 1 and group 7, the melting points of elements increases. No, they don't. They decrease. Okay, statement 2, chlorine can displace iodine from aqueous potassium iodide. Correct. But cannot displace bromine from aqueous potassium bromide. Wrong. It can. So which statements are correct? Both statements 1 and 2? No, both are wrong. Statement 1 only, it is wrong. Statement 2 only, it is wrong. Neither statement 1 nor statement 2, yes. Both statements are wrong. This makes option D the correct option for this question. Question 32. A reversible reaction involves a solid reacting with hydrogen. Okay. Which of the metals, aluminum and iron, would catalyze the reaction and what is their effect on the position of the equilibrium? Okay, so solid reacting with hydrogen requires a catalyst. So a metal acting as a catalyst should have variable oxidation states. So aluminum has only the oxidation state of +3, whereas iron is a transition element, so it has variable oxidation states. So iron could be used, aluminum cannot be used. So options A and B become incorrect because they include aluminum. C and D both include iron only. So now let's look at the other column, position of the equilibrium. Okay, so if iron is acting as a catalyst has no effect on the position of the equilibrium. It only speeds up the rate of reaction. So option C says moves to the right. No, equilibrium position remains unaffected. And option D says no change. So no change would be the correct answer. This makes option D the correct option for this question. Question 33. Iron is obtained in the blast furnace from the ore hematite. Hematite is Fe2O3. Okay, which statement is correct? Calcium carbonate is used to remove acidic impurities. Calcium carbonate reacts with SiO2 producing CaSiO3. SiO2 is acidic in nature. So option A is correct. Option B, coke is reduced to carbon dioxide. No, coke is carbon. Carbon is oxidized to carbon dioxide. Hematite is oxidized by carbon monoxide. Hematite, being Fe2O3, reacts with 3 moles of carbon monoxide. It is converted into iron metal. Now, Fe3 plus is going to iron metal, which is reduction. And carbon monoxide is oxidized to carbon dioxide. So, hematite is oxidized? No, it is not oxidized. And the last option, hematite undergoes thermal decomposition. No, hematite undergoes reduction, not thermal decomposition. So for this question, option A is the correct option. Question 34. The three statements about carbon cycle are given. The carbon cycle regulates the amount of carbon dioxide in the atmosphere. Yes, it does. During photosynthesis, carbon dioxide is produced. No, during photosynthesis, carbon dioxide is used up. Combustion of hydrocarbons requires oxygen. Yes, combustion means burning an oxygen. So statement 2 is wrong, 1 and 3 are correct. So which statements are correct? 1 and 3. So this makes option B the correct option for this question. Question 35. Carbon is used in the purification of water supply. What is the reason for this? To remove mud and other insoluble solids? No, this is done through the process of filtration. Okay, to remove nitrates caused by excessive use of fertilizers. This is not a process for water filtration or water purification. To remove taste and odors. Yes, that's what carbon is used for. To sterilize water by removing harmful bacteria, we use chlorine for this purpose, not carbon. So for this question, Option C is the correct option. Question 36. Octane is an alkane with 8 carbon atoms per molecule. So the formula of octane would become CnH2n plus 2, where n is 8. So C8, H would be 8 to the 16 plus 2, 18. So molecular formula of octanes A and B are incorrect because hydrogen is 16, C and D have hydrogen as 18. They are correct. The question asks us what is the molecular formula, already decided, and how does its boiling point compare with that of butane? Now, butane is also an alkane with 4 carbon atoms, so C4H10, and we are comparing it with C8H18. Now, as the length of the carbon chain increases, the boiling point increases, right? So, octane will have a higher boiling point than butane. So in option C, it says lower than butane, which is wrong. In option D, it says higher than butane, which is correct. So this makes option D the correct option for this question. Question 37. Which equation for the reaction between propane and chlorine is correct? So propane has a molecular formula of C3H would be 3 to the 6 plus 2, 8, C3H8. So A has C3H6, wrong. B has C3H8, C has C3H8, D has C3H8. So this part eliminates option A. And it is asking us which equation is correct. So when C3H8 reacts with chlorine, substitution reaction takes place. So we end up with chlorine replacing hydrogen in the alkane forming chloroalkane, and we have formation of HCl. So in option B, the other product formed is hydrogen, which is wrong. In option 3, the other product formed is C2H5Cl, which is wrong. And in option D, the other product formed is HCl. So all reactants and products in option D are correct, making option D the correct option for this question. Question 38. Propanoic acid reacts with calcium carbonate. The products of this reaction are calcium propanoate and carbon dioxide and water. Which is the equation? What is the equation for this reaction? Now, A and B has C2H5 COOH present. C and D has C3H7 COOH present. So, propanoic acid has the formula of C2H5 COOH. So, this makes option A and B have the correct formula, C and D have the wrong formula. So C and D have been eliminated. So now this would react with calcium carbonate forming calcium propanoate. Now the calcium ion has a charge of +2 and the propanoate ion will have C2H5 COO minus charge. So in order to balance the positive charge, we would need 2 moles of C2H5 COO minus ions. So now, if 2 moles of C2H5 COO minus ions are required, the formula for calcium propionate becomes Ca with C2H5 COO taken twice. So in option A, we do not have this. We have 2 moles of C2H5 COO Ca. But in option B, we do have this C2H5 COO twice and Ca. So option B is the only remaining correct option, and the other products are carbon dioxide and water as stated in the question. This makes option B the correct option for this question. Question 39. The monomer CH3CH3 can be used to make an addition polymer. Okay. This addition polymer has a chain of carbon atoms joined to each other by a carbon-carbon single bond. Okay. Each of these carbon atoms is also bonded to at least one other atom or group of atoms. These are called side groups. Okay. Which statement describes a carbon atom in the polymer chain made from this compound? Every carbon atom in the chain has one CH3 and one hydrogen atom as side groups. Okay, so we have double bond between this and this carbon atom. it has a hydrogen each, and we have a CH3 here and a CH3 here. So this is one repeat unit of the polyalkene. Okay, so statement A, every carbon atom in the side chain has one CH3, yes, and one hydrogen atom as side groups. Yes, this option is correct. B, every carbon atom in the chain is joined to a CH3 CH side group. No, a CH3 is a separate side group and a hydrogen is a separate side group. So this side group does not even exist. C, every carbon atom in the chain is joined to either two CH3 or two hydrogen atoms as side groups. No, each carbon atom is joined to one CH3 and one hydrogen atom. D, every carbon atom in the chain is joined to hydrogen atoms only as side groups. No, CH3 groups are also present on each carbon atom. So this makes option A the correct option for this question. Question 40. Which row correctly shows the structure of a polymer and the monomers from which it is made? Okay, A. Now this monomer has a carboxyl group and an amine group on it. So the polymer, okay, uh, if you look at the box on the left, you have a COOH group, and on the right also you have a COOH group. This is not present in the monomer. And again, if we continue onwards, we have got NH2 on one side of the box and NH2 on the other side of the box as well. Both of these configurations are incorrect based on the monomers. B, we have a double bond. So the double bond will open up. Okay, so when the double bond opens up, we have, okay, look at this. One, two, three, four, and five bonds on carbon. That is impossible. This structure itself is wrong. Next, we have a box with a COOH on either side. That means this box, darkened box, will have a COO on one side, a COO on another side. And if it was an ester, it would just join to an oxygen atom. And if it was an amide, it would join to an NH group. Here, they are joining it to both O and NH. There is no such structure that is possible. The chemistry here is wrong. Option D. Now we have two monomers, one having a COOH group on either side, and this box is slightly darkened, so COOH here and COOH here, which is converted to C double bond O. Yes, this is correct. And on the other monomer in which the box is white, we have got an OH group which converts to O, and we have got an OH group which converts to O. So here, this and this are positioned correctly with the correct type of bonding between the two monomers. So this makes option D the correct option for this question.